Let's apply this to some geometry because I know we all love our geometry. You know, we miss the days of awesome geometry. So it says here, if triangle ABC is a right triangle with the right angle at C, then a squared plus b squared equals c squared. So remember that, the Pythagorean theorem. Ooh, I love it. You know, when we're having a family dinner, all we do is we talk about the Pythagorean theorem and how to use it. It's one of our favorite things to talk about in the Allen family. So, you know, definitely a great conversation starter that you guys can use at dinner later on this evening. Alrighty, let's use it. So we want to find the unknown length in each right triangle. We'll have a couple examples here. We want to give the answers to the nearest tenth. Now I'm also going to add in there, let's leave them in exact, so leave your answers in the square root as well. We'll do both answers because sometimes you will be asked for both. So let's do both here. Well, first off, the most important thing is to identify which one's C, the one that's across from our right angle. So our unknown length here is C. That's the one we're looking for. Now, the 7 and the 9 really can be A and B. It really doesn't matter which one's which. This guy can be A, this one can be B, or vice versa. It does not matter which one's A, which one's B. What really matters is that this one is C. C is the most important one that we get right. All right, the A and B are interchangeable. So what I have here is A squared, so 7 squared, plus B squared, 9 squared, equals C squared, which is X squared. So I'm going to have 49 plus 81 equals x squared. So you get 130 equals x squared. And if I want to find the answer, then I'll have to square root both sides. And I get x equals the square root of 130. Can I simplify that? No, there are no perfect squares that I can divide out of this one. I know that because I've done it before. But if you were to try dividing by 4, dividing by 9, dividing by 16, so on and so forth, you're not going to be able to find anything that divides out that's a perfect square. The other question you might be asking is, why isn't there a plus or minus? So I will ask you, why isn't there a plus or minus in this problem? Oh, that's absolutely right. Very nice. Give yourself a pat on the back. It is because we're talking about lengths, and you can't have a negative length. Even if I'm moonwalking, I cannot moonwalk a negative length. I'm still moonwalking a positive length. So you have to stay positive when we're talking about lengths of segments. Cool. Next one will be our approximate answer. So we want to have our approximate answer. So we're going to have x equals approximately, and the square root of 130 is about 11.4, and it's 0.175. So nearest tenth would be 11.4. So here's my approximate answer. Here's my exact answer. Once again, let's find our unknown length in the right triangle. However, this time we have C, but we don't have either A or B. Now again, it doesn't matter which one's which. We can call this one A this time. We'll call this one B. So I'm going to have x squared plus 6 squared equals 13 squared. So we'll have x squared plus 36 equals 169. We'll subtract the 36, so we have x squared equals 133. And then we'll square root both sides. So my answer will be x equals the square root of 133. Now, can I simplify that at all? Are there any perfect squares I can divide out? After checking, no, we don't have any that we can divide out. So this is our exact answer. And then our nearest tenth, let's plug that into our calculator, and we will have x equals approximately 11 point, and it's 5325, and so on and so forth. So it's 11.5 for the nearest tenth, because that 3 right after the 5 will not round the 5 up. And there you have it.